Welcome to video 13 in a series of introductory videos for InventorCam. This video's topic is HSR. The HSR toolpath is a target-based recognition roughing toolpath. It pretty much is similar to what we saw in videos 9 and 10 in terms of using the target geometry and just laying down a toolpath based off of that solid. So let's take a look at the different models here, different modes of HSR. We're going to start with HM roughing, and that is the default. As soon as you open up your HSR, it's going to go to HM roughing, and you'll notice right away that under geometry, the target is automatically selected as the geometry. So similar to other recognition toolpaths, we start from there. Under tool, I already have my half-inch selected. Tool selections we covered in video 2. You can see that we have under data, we have our different feet and speeds, and we have our coolant options, similar to what we've seen in other toolpaths. The workflow is generally the same. In the HSR toolpath, we use constraint boundaries. It's similar to the working area you would have seen in the 3D iMachining and the 3D milling toolpaths in videos 9 and 10. Here, it just happens to be called constraint boundaries, but it works exactly the same way. In this case, it actually can default to the automatically generated one, which is just really just the outside edge of the entire part. Or you can click on created manually and then choose the contours like you do with every other toolpath. You just choose the edges of the solid or a sketch. Tool relation, similar to what we saw in those other videos, where you can tell it to either do external, internal, centered, or tangent. So for a better description of how that actually works, I'll refer you to video 9, where I cover that in a little more detail. Under passes, we get the main parameters of this toolpath. So the passes section is similar to the technology section in other toolpaths. We have our wall offset, floor offset. Again, this is a roughing toolpath, so we're going to leave some material behind. We have our tolerance. This is because this is a recognition toolpath, and this part might be a translation. It might not have translated properly, so we might need to add some tolerances just to kind of better fine-tune our closeness to the surface geometry. And we have a step down and a step over. Now, the step down type, it could be constant or constant with flats. Essentially, all I'm doing here is it'll analyze the solid and see if there's any flats, and then do those flats in addition to the surfaces. And that's similar to what we saw in the 3D milling toolpath in video 10. Now, the step over type, you have 3 options. And basically, these 3 options are just how it analyzes a solid and what step over it does in which direction. So a core would be understood to be a boss. It would go from the outside inwards towards that boss, towards that core. Cavity is the opposite. It assumes that there's a pocket, you're on the inside of a pocket, so it would go from the inside outwards. HM spiral is basically a combo of the two. It analyzes the part and will generate step overs based off of the cores and the cavities. Top right corner, you can see here that you have Z top and Z bottom. That is just the limits of the toolpath. So it's going to analyze the solid between those 2 Z levels and only machine what it finds in the Z direction between those 2 Z levels. I have the smoothing box checked here. That's simply to just turn any kind of small line segments into arcs. If I click on advanced, we can see that we can control what those radii actually end up being. Under step down, we're just going to optimize the Z level, so it makes sure that it flows down in the Z level appropriately. And under edit passes, I could actually leave this unchecked and machine the entire part. It actually compares the stock and the target and machines everything. Now, since it analyzes it to the stock definition, if I check this box, I can actually tell it to go to the updated stock or to a STL file that I brought in there. So this is just a way to trim any kind of air cuts. So if I'm not starting from a block material, but I'm starting from a casting, or I'm starting from a previously machined part or something like that, I can trim out the air cuts, I can edit the passes so that it doesn't waste any movements. Under link, we control the cutting direction, so climb, conventional, or bidirectional, meaning it'll just zigzag back and forth. If I wanted to further refine the toolpath, let's say there's some areas where I just wanted to stay within a certain area, link those two, link to Z level. There are different ways to control this toolpath, and a lot of them are case-by-case basis. Under ramping, I can tell it how I'd like it to get into the part. So if I want it to work its way in, I can use profile or helix, or if I just want to plunge in, it'll just plunge right into on the side or into the pocket. As soon as you click on any one of these, it opens up the parameters related to that particular feature. Everything else on here is to further refine the toolpath. That's why if you turn off advanced, generally you only really get the first two, because again, case-by-case basis, you might need to actually do something a little different to address your particular part. But in general, the defaults are usually okay. If we exit out of here, take a look at that toolpath, you can see that there are some areas where it's approaching from the inside, the outside. This is the HM spiral. It's analyzing the part as much as possible to see exactly what flow it should take. And I'm using the plunge ramping, so you can see that it just kind of plunges in with a feed movement. Take a look at one of the other options in HSR, contour roughing. So the next two toolpaths, actually the next three toolpaths I'm going to cover, have names similar to what we've seen before in the pocketing and the 3D milling toolpath. In this case, contour is a contour style step over. It's going to do a racetrack style, it's an offset style. And because it's still HSR, a lot of this is the same as what we just looked at. So the target base, still using that half-inch tool, still using the same constraint boundary. Under passes, we still have wall offset, floor offset, tolerance, step down. But we now have offsets, minimum and maximum. So that's because you're doing a contour style. It's really adaptive. So maybe you could just put in a minimum, but if you wanted to set a maximum as well, you could. You can detect the flat areas of the toolpath, and you can detect the core areas, meaning that if it recognizes that there's more of a core feature on this part, then it'll adapt the toolpath so that it still does contouring, but it does it around a core. Adaptive step down allows the toolpath to recognize that even though I'm doing my 100th step down, or in this case, my 100th step down, there might be features like a flat face or something like that that falls in between that step. So rather than just having a uniform 100th step, it'll go back and machine a flat area with these particular parameters. And once again, edit passes, I could check that box and get it to automatically recognize that some material has already been removed. Depending on the stock definition, the updated stock, I can go in there and clean that up. Everything else is essentially the same. So let's just exit out of here. And we can take a look at that toolpath. So it doesn't look all that different from the HM roughing, but that's because on this particular part, there are a lot of cores, and I told it to detect core, but it is still a contour style step over. Now let's go to the next one, the hatch roughing. So again, hatch, same sort of name that you would see in the previous toolpath. It is a zigzag back and forth across the part in a particular direction. But it is still HSR, so we're still using the target geometry. We're using our half-inch tool. Constraint boundary is the same. Under passes, the window almost looks exactly the same. We have wall offset, floor offset, tolerance, step down. We have detect flat areas. So again, if we're doing hatching, it can detect the flat areas of the part and address those flat areas separately. We have smoothing, and we have step over and an offset from the edge, in case you wanted to stay off the edge by a certain amount. But the step over, you can see that it has literally just step over of the zigzag, the Z top, Z bottom. But here we see the fact that we're doing a hatch, we can tell it what direction along the part we'd like it to go. So similar to what we saw with the HSS Express in video 11, we can tell it that we can go in one particular direction. So either linear, either a value off of the x-axis, or we could choose line and choose 2 points to define the angle we'd like to go. Adaptive step down and passes similar to what we saw before, and the link section is similar to what we saw before. All you're really doing is telling it to go in a different direction with the tool. In this case, with the hatch, you can see that it is much more of a linear toolpath. It just goes back and forth along whatever direction we told it to go. And lastly, we have the rest operation. So again, similar to pocketing, similar to pocketing, profile, 3D eye machining, 3D milling, pretty much anywhere where you see the word rest, it does the exact same thing. It's a little different in HSR because even though we're calling it rest roughing, it operates the same way. We're just using the edit passes. You can see though that it has it automatically put in. You can't actually turn it off because this particular toolpath always needs to analyze the updated stock. Everything else on this window is exactly the same. You have detect flat areas, smoothing, detect core areas, Z top, Z bottom. It is simply just analyzing the part and removing the excess material, whatever was left behind. And if we take a look at that with this 1/4 inch end mill, I'm just going in and I'm just doing the tighter areas that the 1/2 inch end mill could not do. Any questions on this or anything else from InventorCam, just give us a call at 1-866-975-1115, extension 2. You can send us your parts or your questions via the ticket system at solidcamsupport.com. And stay tuned for the rest of the videos in this introductory series. Thanks for watching.